Hey, this is Brock Lemires, and in this video we're going to talk about functions, and we will introduce functions and we'll start with what we call user-defined functions, which are those that we create ourselves. Okay, so let's do a little reminder of what a function is. In math, a function is a relationship or an expression involving one or more variables. So a classic function might be y is equal to x squared, okay? And on the left is what the output is, or the dependent variable, and on the right is the what you plug in, or the independent variable. And you basically plug in x and you get y, okay? Same thing here. Sum is equal to a plus b. Very simple, all right? So these are functions. You could also write them like this, where you could say, for example, this is a function of f. So f of x is equal to x squared. That means that the function is dependent upon the variable x. And in this situation, you could say g of a and b, meaning that the function g is dependent upon the values of a and b. Now, I want you to think about that, because when we code these up in C, that is the form that we're going to use to basically define the functions. We have to give it a name, which would be f and g, and we have to give it the inputs that are coming in. And of course, this is a C program, so we're going to also give it the data types. All right, so functions are very powerful in C because they also provide a way to organize code. So if you ever have any statement or group of statements that you keep writing over and over and over, even twice, you should consider putting it in a function so that you can just call the function and just basically make your code more readable, make it more concise. And really what it does is it allows you to test the functions and know that it actually is accurate, so that when you use it the next time, you know that it's not going to have any typos in it and everything's cool. It's also a way to break down a program into smaller parts. And so this is called modular design. So imagine that your main function is nothing more than calls to other functions, and you can break these functions out to different engineers, and the engineers all work on their own functions and test them separately, and then integrate them into the larger program. And this is the recommended approach to coding. In this class, our programs are so small, we kind of just say, oh, we'll just stick everything in main. But once they get larger, we're going to have to do that. All right, there is always one function in C, and it has a unique name, and its name is main. So when I type M-A-I-N, that was not made up by me. That was defined in 1972 in KNRC, right? This was the original function. You can never change the name of this. You have to have main. That is what the compiler will look for. It always looks at that, and it puts that as the place that where once it's inserted in memory, that's where it's expecting the first kind of instructions of your program to go. All right, so main is always there. Okay, so here's how you create a function in C. The syntax is at the top. What we're going to do is, let's start with the function name. So you're going to create your own name, and you just got to make sure that it doesn't match any other of the reserved syntax in C. So you can't call this your function. You can't call it int or double. And then over here to the right of it is going to be your parameter list. In your parameter list, you are going to give it the name of the variable coming in, and that variable will also have a type. So you're going to give it a type and a name. And when you do that, it essentially sets up an internal, or what we call a local variable, just for use in this function. Okay. And then if your function returns something like the output, you're going to put the return type over here on the left. And then the way that you do this is inside of the function, which is encapsulated in curly brackets, you will have statements. Okay. And you can also set up other variables that you might want to use. And then when you're all done, this return statement that we've seen so many times in our main function, we basically return the variable that we want its value to come over here and be returned. Okay. So let's look at an example. Y is equal to x squared. All right. This function, we'll call it f. Okay. So this will be like the f of x function. Notice that the name is f. And then over here is the parameter list. Notice that the input parameter is going to be called x. When I do that, it creates a local variable called x for me, and you give it the type, which in this situation is int. Over here, this int is going to be what you return. So consider this. If you're going to have int inside of here in the curly brackets, I create a new variable called y, and I say y is equal to x times x. Now y has the value that I want to return. You simply put return y, and that will be returned to whoever calls it. Let's do, and then this is how you call it. Inside of your main void, all you do is simply say y is equal to f, and then you pass it the input. Now, when you pass it the input, this example is passing 5 into here. This 5 gets passed in, and it's stored as a variable, local variable temporarily called x, used in the function, and then it returns a value, and that return value from the function f would go into my variable y, which is in main. A couple things to keep in mind. The y that's in my main is a variable. The y that's up here is a variable. These do not see each other. Okay, these are y is only seen within this particular function, and this y down here is only seen in this function. Okay, and that's this notion of local variables, so it's not seen globally. All right, now you got to say, where do functions go? Well, let's start with putting them at the top. When you have a main program, main function down here, if you call the function before you declare it, C won't know what to do. It'll be like, error, I don't know what this is. You're calling this thing called F. I have never seen this before. So in that way, you can define your functions before the main function. And this is what they look like. You basically just put a comment header. You say, this is going to be a function, knock out your function. And then when main calls it, it knows, or the compiler already knows where it's at and what it's called. All right, nice. Now, let's see here. Let's do it. So let's just code along. This is the best way. All right, so I'm over here. I'm logged into the Linux server. I'm in my home directory. I'm going to create a folder for this module called mod07 code long. And I'm going to change into that directory. So I'm going to cd into mod07. I'm going to hit tab to autocomplete. Okay, so now I've got that. And I go ahead and check out what's in here. Nothing's in there. I'm going to start a new C program called functions1.c. Let's go ahead and move this over just a bit so you can see. And what we're going to do is create a C program. So I'm going to go I to get into insert mode. And let's do a comment header, playing with functions. And then we'll go, and we're going to do our include standard IO, because we're going to use printf. Of course, standard io.h. And now let's do some functions. So functions to calc f of x equals x squared. All right, so what I'm going to do is I'm going to say, this is the line that declares the function. Okay, so I'm going to have a return value of int. It's going to be named f, and then in the parameter list, I'm going to say I want a variable called x, and its type will be int. Okay, so that's the way I think about it. All right, now open a curly, close a curly, and now inside of this thing, what are we going to do? Well, what we're going to do is calculate, we're going to take x, multiply it by itself, and then return it. But I need a local variable to hold the value of x times x before I return it. So I declare a local variable called y, and then I'm going to go y is equal to x times x, and then I simply say return y. That wasn't even return. So return y. And that's it. Okay. So then, and that is my function. Okay. Life is good. All right, let's call it. Let's go ahead and call this buddy. And what I'm going to do is down here now, I'm going to say main function. And here I go. So I'm going to create my main function, and we'll do it just like we have in the past. I'll go int main void, and then I'll open curly, come down here, return 0, and then I'll go close curly. And now I'm going to come up here, and I'm ready to go. So here's what I'm going to do. I'm going to create two variables, var1 and var2. And what I'm going to do is I'm just going to call this function. Here's how I call it. I'm going to say var1 equals f. And what that does is it says, I am calling f. I'm going to pass it a value. Whatever it returns, I want to store into var1. So I can pass it in just a number as long as it's an int. Okay, so if this function call is going to pass 109 into this function, it'll be received as the local variable x. It will be multiplied by itself, stored to a local variable y, returned to as the function returns and ends. This now comes down to here and is assigned to var1. I can do that again if I wanted to do something like this. var2 equals f, and let's pass 22 in there. So now let's do this. Print f, and I'll say like 109 squared is, and then we'll go %d, format specifier for integer. We'll do a return, and then we'll say var1. Okay. Now I'm going to copy this line. I'm going to go escape to get into normal mode. I'm going to go YY, then I'm going to press P. That copy that line. Now here I'm going to go 22 squared is, I'll say var2. All right, so now let's go ahead and run this little buddy. So let me come on over here. I'm gonna come down here. I got to get into my mod 7 directory. I hit mod 07, then hit tab for autocomplete. I check out what's in here. There's my function. It's called functions1. I'm going to go ahead and say gcc functions. I'm going to tab to autocomplete, direct the output into an executable called functions1, and I run it. Worked well. Let me give myself a little more room, and let's do it with warnings all on, and life is good. So now I'm going to go ahead and run this. I check it out. There's my executable, functions1. Let's go ahead and do Sunny Holland functions1 / means look for the function in this folder. The folder I'm in, don't go search the Linux path. I go boom, oh my goodness, 109 squared is that, 22 squared is that. I did it. How cool is that? Okay. Now let's do another function. Let's create another function and see how this can become very modular. So now I just go up here again and I can say function to do calc g of a and b is equal to a plus b. Okay. All right. So here we go. Here's what this one will be pretty simple. I'm going to return an integer. The name of the function is g. The two inputs are a and b. They're both int a, int b, and then open curly, close curly. Now, this a and b in here, these are local. You can name these anything you want. Okay, name them anything you want. In this situation, I'm going to just simply do a shorthand where I just say a plus b, and I'm just going to return that. So all I did is say return a plus b. It's a simple way to do it and without setting up another variable, and it's good to go. All right, so let's come down here and let's do this. I'm gonna come down here and I'm gonna call my function g. Let me delete these lines so you can see it just a little bit. All right, there we go. So come down here, and what I'm gonna do right now is I'm gonna create, I need a variable to return to hold what comes in. So I'm gonna do int var sum. And I come down here now and I'm gonna go var, here we go. Var sum equals, and I'm going to say g, and I'm going to pass in var1 and var2, and life is good. All right, so now I need to print that to see what happens. I'm going to say printf, I'm going to say var sum equals, do format specifier d to print a decimal, integer in decimal form. I'll say var sum. Okay, so there it was. Nothing more than just another function, but it shows that I can have as many of these little fellas as I want. Okay, so I can have tons and tons of those up there. So let's come down here and let's run this thing. So I GCC with wall, I run it, and oh my goodness, var sum is 1, 2, 3, 6, 5, and that's awesome. And it's adding these things together right here. Okay, so this is phenomenal, right? We have done it. We've created functions. Sweet. All right. Let's also look at functions that don't have inputs. Like, how can it not have an input? Sometimes you just want to return a number. So watch this. What if I did this? I just come up here and I'm like, function to return value 5. So I'm going to return 5. So it's a type integer. I'll call it get 5. And I'll just say nothing. Nothing on the end. And you're like, what? Void means nothing. So that's what you put in there to say nothing's coming into this. And all I do is say return the value 5, and that's a function. And that's it. So now I come down here and let's see. I got to call this little buddy. So let me run out of room here, aren't I? Come down here. Let's come up here. I'm going to go like this. I'm going to create an integer called var3, and I'll just simply go var3 equals get 5, and I'm not gonna do anything. I don't pass anything in. So down here, I don't have to put void. I just basically just put empty parentheses, and void tells it that there's nothing coming in. There's no data type that needs to be set up, and so I'm good to go. So I can now do printf, and I can say I got format specifier of %d means print the integer in decimal format. Go ahead and line return it. Print var3 on this print statement. And let's see what we got. Okay, so I'm going to go ahead and compile this little guy. Oh, I got 5. Okay, that's pretty sweet. So that's a function. We've looked at functions that have inputs and outputs. We looked at ones that only has an output, no inputs. What about only outputs? Only outputs seems weird, but think about what if you want to print a menu, right? So let's do one that's just printing something, okay? So print menu or something like that. Oh no, print your value. So we'll pass it in, print your value. So we'll pass it in something and have this print it. So how do I denote that I'm not going to have an output? In the function, you have to put void, okay? Then you can do print val, that's by user defined name. Let's bring in an integer called x. And all it's going to do is say, you know what, printf, your value is format specifier %d, and go ahead and line return it. And please print what came in, which was x. Go ahead and close the curly. Actually, you got to do return, but you don't need to return anything because it's not returning anything to void, but you should return just to end the function cleanly. And life is good. So now watch this. I come down here. Let's see, still are having not much room here. So I come down here. I want that on the screen. So let's do this. I'm going to go print val, and I'll pass in var3. And now watch this. Notice that when I did the function, it didn't have any return value, so I didn't have to put like var x equals print val. You just put print val because there's nothing returning on it. So in theory, this should print var3. Okay, so let me do this, and I'll go ahead and compile it. Go ahead and run it, and there it is. I got 5. Your value is 5, and that was from this function right there. Okay. Pretty good, pretty good. You can also have ones that don't have inputs or outputs. And this would be like printing a menu would be interesting, where all you do is you just say, I'm going to call print menu, and it's going to have no inputs, no outputs, and all it's going to do is a set of print statements. There's no variables moving in, no variables moving out. And then that's basically functions. Now, at the same time, one of the interesting things that you can do is once you get a lot of functions, you can tell over here, like above main is getting huge, right? I'm starting to have like a lot of lines of code before I even get to main. And it's like, man, that's kind of a hard to read, sorta, and you can tell that it gets out of hand. C allows you to declare functions above main without putting the code there. And they are simply called function declarations or function prototypes. And what you do is you just put the first line of the function, which has its return type, the name of the function, and its parameter list, and then you just put a semicolon. And when you do that, C will read through this and say, okay, I know this person's going to make a function called f, and one called g, and one called get5, and one called print value, and I will allow the main function to run, everything's good, but I need these somewhere. So that's where you can then take the actual function statements and put them below main. So that's how you're able to put them at the bottom of the thing. Okay, so now you got to ask yourself, what should I do? Because I could even do functions prototypes or function declarations, and I could put them in separate files. All I'd have to do is make sure that I include the separate files. And this is actually really the way you should do it. If you have all these different functions, life is good. Make one called f.c, g.c, get5.c, printval.c. Make 4 different files that each just has its function. You then just simply include them in main, and everything is great because these are now files that other engineers can work on and debug, and everything's great. So the question then becomes, what are we going to do? Okay, what should I do? Well, what we're going to do is kind of the rule of thumb is like for programs that are relatively small, like less than 100 lines, you can put the functions before main. And that's where you can almost see the whole thing. If you printed it out on a page, you could see, oh, there's my functions, and then they're called by the main program, everything's good. Once you get above that, you want to start breaking your functions into separate files. Then you start putting the function prototypes or the function declarations above main, and then you have to include all the other files. And the way that you do everything is with what we call a make file. So the pound includes can either go in main, or you can actually have another file that instead of like GCCing main or GCCing your file name, you actually make a file that like calls f.c, g.c, get5.c, print out, and then calls main. And that's how you manage all your files. Okay, that is it. Functions are very powerful, not that difficult, but once you start thinking about like putting stuff outside of main and inside of main and all this, you start running into a little bit of errors. So you got to stay organized, but that is how you do it. And that's it.